So in this video we can have to discuss much about how we can be able to solve and some problems to do with a free fall motion. Having gone through all the cases to do with a free fall motion, we talk of actually one-way up motion and one-way down motion, and even ground back to ground case where the object is released from the ground level and back to the ground level. And finally we discussed about actually the case where the object has been released from the top of the building and back to the ground. So take note of that. So actually before this lesson, you just have to go through those actually cases, because those they are the ones that are going to use in the answering of this question. So all these questions will be answered based on those cases we discussed before. So pay attention. Now question A says should be a stone thrown from the top of the building is given an initial velocity of 20 meters per second straight upward. The stone is launched 50 meters above the ground. So which means this is a top up ground case where the object is released from the top of the building. So let me just have to come up with a sketch presenting the information. So this is the actual case, which means this should be a height of 50 meters, and the stone has been launched and going off like this. So which means this is the weight, so it should be that. And the stone has been given the initial velocity given as 20 meters per second, so it should be 20 meters per second. 20 meters per second. That is like that. Now, and the stone just misses the edge of the roof on which it's down, which means it went straight down the ground. A. Determine the time at which the stone reaches the maximum position. We're looking for the Tmax. Tmax. That's what we're looking for. We're looking for Tmax. So mind you, this is the maximum point with a final velocity given as Vmax, and it is always given as L. So now, since we have the initial velocity given as 20 meters per second, and we have the acceleration due to the gravity, which is given as 9.81 meters per second square. Now, how should we be able to have the Tmax if this is the case? So now, we are going to use the acceleration formula. Now that is being given as, let me just have to create some space here. So we are looking for Tmax. That is, so having the initial velocity as well as the acceleration due to the gravity in the final velocity at this point. Now we use this formula, which is given as a Vmax is equal to negative GDmax and plus U. So where Vmax is given as L, which is equal to negative 9.81, should be in 9.81. And that times Tmax, and that plus 20 meters per second square. It should be 20 meters per second. So just that. So now, which means we'll have a Tmax that will be given as, now we'll have it as negative 20 divided by, should be 9.81. Actually, we have 20 meters per second, and we'll have negative 9.81 meters. Of course, that will be given in seconds overall. We'll have it in seconds. So that will be given in actually seconds. So what is that time? So which means we'll have it as now 20 divided by 9.81. That will be given as 2 seconds. So that is giving us 2 seconds. So it should be giving us 2 seconds. So that's the time in which the object has to move from the top of the building to the maximum point. That is 2 seconds. So now you get it. So we are using the same formula as we discussed before in the analysis of this case of the freeform motion. So just have to go through before this lesson, because we just have to apply those active formulas. And our question B says that find the maximum height attained. That is, now we are looking for, should be this height. So what is the maximum height attained? Now you see that the maximum height, let's say, so now the maximum height would be the combination of this height and also the height of the building as well, or the height that we have. So that would be the maximum height attained. So which means we'll have the H max. That will be given as, let's say the height of the building is given as A. So have it as A plus, and this height on top there, or have it as A plus B. Let's say that is given as B. Now what would be the height which is given as B? So now you should have clicked on the way we analyzed about how you can be able to have the height on that way. So what is that on? So now we'll have that on using this formula. That is given as, should be that of, now V square, that is V max square, is equal to U square minus 2G. Instead of having should be H, we'll have it as a B, because we symbolized it actually a B. So have B. So we have the V max being given as L, so have it as a L, which is equal to the initial velocity is given as 20. In the square of that one, we have it as a 400. Minus, now what is 2 times acceleration due to the gravity? So now we'll have it as 2 times 9.81. That is given as 19.62. So now we'll have it as 19.62b. Then I will have to transfer those to the other side. That will give us this case now. So now we'll have a b is equal to negative 400 divided by negative 19.62. We'll have that in meters. So what is that one? So now we'll have 400 that divided by 19.62. Now that would be given as, should be a 20.4 meters. So have it as a 20.4 meters. So that's the height of, that is the height from the top of the building to the maximum position. So we discussed a lot of formulas that you should have to use in the analysis, but we are using the formula actually the one according to the parameters that we have. It will work. So that is, so now therefore have the maximum height attained now being given as, now we'll have a 50 meters plus 20.4 meters. That will be given as now 70.4 meters. So that is, of course some books you see them presenting the maximum height attained only being the height from the top to the maximum point, but it is the same as that. Just have to, whenever you ask it to have the overall maximum height, it means we are looking for the whole of this one. But sometimes whenever they says find the maximum height attained, they may refer to the height from the top of the building to the maximum point. Of course, that is also should have to calculate up to this point as well. So just have to know that that is based on some box, but that's the maximum height attained from the level ground, that is. So take note of that. So maximum height attained, that is from the level ground. So that is. Now, in the question C, determine the velocity of the stone when it returns to the height from which it was thrown. So we are looking for the final velocity at this point, where the object, we are looking for the final velocity at this point when the object is being returned to from where it was thrown. So the object was thrown from this height. So we are looking for the final velocity here. So it is the same way we analyzed about that case of ground back to ground case. So it is the same way. It is like we have this case of the actual free fall motion, where now we are looking for the final velocity, which is this one. So it is the same way, just have to know that. So what is the formula to have to use there? So it's either we use this formula, so that is giving us v square is equal to u square minus 2g should be, let's say, h. So where this is the actually final velocity we're looking for, this is the initial velocity, and this is the acceleration, this is the actual displacement, of which the displacement is given as L, because from here and back to here it means the displacement is given as L, as we already discussed that and about. So have v square is equal to, what is the initial velocity? We have it as a 20. Now to the power 2, have it as that in meters per second. The minus, or have 2 times now acceleration due to the gravity, which is 9.81. So by the way, we already have a minus here corresponds to negative g. So as we'll be substituting the value there, we'll have it as a positive in the times cell, because the displacement is given as L. So you see that the whole of this one will be given as L. So just have to take it out. So now we'll have v square being given as 400. Now the square root of v square is given as 20 as well. So which means the final velocity will be given as the 20 meters per second. Now it should be a negative, because it is pointing downwards, so will be given as the negative 20 meters per second. And this is what we discussed as well. In this case, the initial velocity will be equal to negative the final velocity for this case of the free fall motion. That is from here up to this point. So that much we discussed about, in case you actually forgot that, but just have to know the way we discussed before. So as I already actually asked you, just have to go through those lessons in case you missed them, because everything was actually, we discussed everything. Whatever we're doing here, nothing's new. We already discussed all this. Or else we can also have that final velocity using this formula. That is given as, now should be that of v is equal to negative gd. Now this t will be given as a d total, and that plus initial velocity. Now what is this d total? So since we're talking about this nature of the free fall motion, so now the d total will be given as 2 times d max. So the d max we obtain times 2 will have it here. We'll be able to have the final velocity at that point. So take note of that. And let's go for another question as well. So the other question says that it should be, find the velocity of a stone as it strikes the ground. Now we're looking for the final velocity at this point. So what is that one? The way we discussed it before. What will be the final velocity in this niche? So the formula says that we'll have it as v. The v should be this now. We discussed it as v should be a v square is equal to u square minus 2g should be h. Now of which this is the final velocity of interest, this is the initial velocity, acceleration due to the gravity, and this is the actually displacement. So now we discussed that for this nature of the free fall motion, the displacement is the height of the building. That will be presented as the negative. So now which means we'll have it as a v square is equal to, now we'll have a 20 to the power 2 minus 2 times 9.81 in that times the height of the building, which is given as the negative 50. So what's that? So now we'll have 2 times 9.81 and also times that's it should be a 50. So which means we'll have it as a, now it should be this. What's that? It should be 2 times 9.81 and times 50. Now that will be given as, now have it as, now have 400 and plus should be 98, should be that, and of course we'll have that as that. So now plus 400, we'll have it as 1318. So have it as 1318. Now we'll have it is, in this case, of course we'll have meter square per second square. So that is, now have to introduce square both sides to have one need to solve for v. Now have the v be given as, now the square of 1318 in meters per second. So what is that one? What is the square of that one? So have it as 37. Let's now have it as a 37.2 meters per second. So that's the final velocity of the object as it strikes the ground. Now you can see that the final velocity is not the same as the initial velocity, because this case of the free fall motion is not symmetric in nature. So have that. You should also try to solve all these parameters using the other formulas we discussed about the time we were analyzing this case of the free fall motion. You see that the answers will also be the same as well. So just that actually just to add in, try to have the total time for the whole entire journey. So try to have to solve for the total time and for the whole entire journey using the formulas we discussed before. So try that one out at your own time. Now also let's try to go through this question as well. The question says that a baseball is hit so that it travels straight upward after being struck. Now find the bat actually it should be by the, after being struck by the bat. A fan observed that it takes 3 seconds for the ball to reach its maximum height. So find the ball's initial velocity as well as the height it reaches. So this is the one-way up motion, and actually for the free fall case, so which means this is the case you have to know. So which means this is the case. So just looking at the problem itself, just have to know that which case is this. So that's the humble duty of yours to know all those things. So which means we have now this case. So which means we have the initial velocity given as, no, we don't know what is the initial velocity, by the way, but now this is the maximum, a point. So maximum point where Vmax is given as L. So that is, of course, we know that the acceleration due to the gravity will be given as negative 9.81 meters per second square. So take note of that. That's the one-way up motion. So we have been given the term text given as Tmax. So given as actually as the Tmax, which is given as 3 seconds. So now the question says that find the ball's initial velocity. So what's the formula? As we discussed before. So have Vmax equal to negative GD max and plus U. Now since we have this one as 0, we'll have it as should be 0 is equal to negative 9.81 a Tmax should be plus initial. That should be Tmax. We know what is Tmax. It is already being known, so we'll have to substitute there. That will be given as times 3 and plus that of the initial velocity. So what is 3 times that one? So 3 times 9.81, which means we'll have it as to 9.43. So 29.43 is equal initial velocity. So should be in meters per second. Upon having this one out, you transfer this side, then you have it as a positive. So that is so, which means initial velocity is given us should be 29.43 meters per second. So we have just we have just reversed the two, this one here and this one here. So that is the same as that. So that's the initial velocity. So how about the maximum height reaches? So which formula should we have to use to have the maximum height? So try that one at your own time to have the maximum height. And I also always try to go for this problem as well. It is possible to shoot an arrow at a speed as high as should be 10 meters, actually 100 meters per second. The first stop. If friction can be ignored, how high would an arrow launched at this speed lies if shot straight up? So we are looking for the maximum height. And B, how long would the arrow be in the air? Now we're talking of being before it strikes the ground. So which means as it stands here, how long would the arrow be in the air? Now as it stands here, which means this case of the freeform motion, it is given as the ground back to ground case, where the object has been raised up and it has been fallen to the ground back. So that's the case of the freeform motion. So let's have to come up with a sketch of that motion, that case. So the object has been raised up and it turns back to the ground. So we have it as that. So we have been given the initial velocity being given as 100 meters per second, and we know that that should be that. So we know that this is given as a Vmax. So this is given as the Vmax is equal to 0 at this point. So that is. So now the question A says that we should have to calculate actually the maximum height, which is given as this. So what is that one? So have V square is equal to, should be U square minus 2GH. Yes, now we have this one is given as Vmax. By the way, Vmax. Yes, now we'll be able to have the maximum height using this formula. Much as we have the initial velocity given as 100, you'll be able to have the maximum height there. Try to have that one at your own time. Feel free to finish that one out. And B, how long would the arrow be in the air? We're looking for the d total. So there we are looking for the d total. So either we can use this formula, actually the displacement or the maximum height, or should be displacement is called u d total minus half g d dot square. So that's the formula. So where this is the actually displacement that will be given as L. I understand you can remember about that case of the free fall motion. So that is, we are given the initial velocity, which is given as 100, and I'll have times t, and minus, we'll have this one out. So we'll be able to solve for d dot on that way. Anyway, what is half times 9.81? So what is 0.5 times 9.81? So it is given as 4.9. So which means we'll have this case being given as a 4.9 d dot square. So in this case, we'll have to factor out actually a d dot in both cases. So now which means we'll have it as a d dot is equal, now should be this d dot, that should be 100 minus 4.9 d dot is equal to 0. So which means we'll have to have this one equal to 0 for us to be able to solve for t. So that will be given us in this case now. So practice will make you perfect. So now have 100 minus 4.9 d dot is equal to 0. So this is the same as negative 4.9 d dot is equal to negative 100. So you have to divide both sides by negative this one to have the d dot. Or else you can also use this formula as well. Whichever. You can also use this formula, where you can have to, you should have to know that the d dot is equal to 2 times t max, where you could have to solve for d max. What is the d max? You could have used this formula. V max is equal to negative g d max, so plus u, where this is the velocity at the maximum point, and this is the initial velocity. You'll be able to solve for d max. You put it here, you'll be able to have the d dot there. So try to go through that one and see how you can be able to have that one out. Now what if I were to have the final velocity of the object as it strikes the ground, of which could be this formula now. V square is equal to u square minus 2gh, where this one could be 0. The final velocity could also be the same 100, but it could be negative 100 meters per second. Or else you could have used this formula as well. That is given as a v is equal to negative gd dot plus u. That is where now this d dot could be obtained. That is upon having the actually a d dot. So that is upon having the d dot. So it should be what? What is the question overall? What's happening there? And now could be this formula as well, where this is given as d dot. So you'll be able to solve for the final velocity of the object as it strikes the ground, in case you ask it to have that one out. So try to go through that one if you may think of having that. Now let's consider this question as well. A boy is thrown directly downward with an initial speed of, that should be this, and from the height of this one. Now after what time interval does it strike the ground? So this is the one-way down motion, where the object has been released from the top. That should be this. We have the initial velocity given as, it should be 8 meters per second, and we have the height being given as 30 meters. So we are trying to have the time, of which the acceleration to the gravity will be positive 9.81 meters per second square. So try to have the time that way, the way we discussed it before. And also, let's try this question. A student throws a set of keys vertically upward to her sorority sister, who is in the window 4 meters above. The second student catches the keys 1.5 seconds later. So with what initial velocity were the keys thrown? Thus, now you can see that this is the one-way up motion. That is the one-way up motion. So that's the one-way up motion. The keys were thrown with initial velocity that we don't know, but the height is given as 4 meters. And the time for the whole entire journey is given as, should be Tmax of course, is given as 1.50 seconds. So that is with what initial velocity were the keys thrown. Of course, you can use this formula. Displacement is given as ud minus half gd square. So where we have the d's, so have the height, which is the displacement, to be able to have the initial velocity. And for you to have the final velocity as the keys, now in this case, you can see that the final velocity is no longer zero. So the final velocity is no longer there, actually is no longer zero, because we are considering the velocity as the keys were to be caught in this case. So what would be the final velocity here? So now we use whichever the formula. Let's say this one can also be able to work, that is, or whichever according to the way discussed. So try to go through that one. So let me also try to highlight to you the way this question can be actually tapped up. Now you throw a ball vertically upward from the roof of a building. Full stop. The ball leaves your hand float at a point evenly with the roof falling, with the roof actually rolling with upward speed of 15 meters per second. So which means this is the case now. This is the building, and the ball has been thrown vertically upwards, and that goes like this. And now we have the initial velocity given us should be 15 meters per second. So that is, we are not being told about what is the height of the building, so we are not much interested in that one at first. We know that this is the actual maximum point where Vmax is given as 0. So that much you have to know. Now the question says that find the position and the velocity of the ball 4 seconds after leaving your hands. So we are looking for the position, which is the displacement, or which is the height, upon having the time given as 4 seconds, if this is the initial velocity given as u. So we should have to look for the displacement or the height, and also the final velocity as well, if that's the case. So how should we be able to make that an up to? So we use the displacement formula to have the we use the displacement formula in order to have, what's the question here? Find the position of the velocity. In order to have, that should be, we have the initial velocity given as 15 meters, by the way, 15 meters per second. So in order to have the height or the position, we need to use this formula. Height is given as, now should be given as h is equal to ut minus half gd square. So that's the formula. We have the initial, we have a time, and the acceleration to the gravity is given also is given. We'll be able to have the height or the position using that formula. Of course, that is, in the other part says that you should have to calculate the final velocity, of which you can using this formula as possible. V is equal negative gd plus u. You'll be able to have the final velocity there properly. So have that in mind. And part C, find the velocity when the ball when the ball is 5 meters above the rowing, so we need to have the we need to have the final velocity when the height is given as 5 meters from the initial velocity being given as 15 meters. What formula should you have to use to have the final velocity in that way? So use this formula. V squared is equal should be u squared minus 2gh. So you'll be able to have that out since we have all these parameters. So try to have that out on your own in that way. And the other question says that find the maximum height reached. So we need to have the maximum height reached, so which is now should be this case now. So we need to know what is the distance from here up to this point, which is this distance. So we need to have that one. So we don't care about the height of the building because we are not being told about that one. So have this height, of which you know how you should have to have that one out. So try to go through that one, and even the Tmax as well should have to, and the time at which the reaches there should be maximum a point. We need Tmax, the time takes for the object to reach at this point from this point. So that is. So on the maximum height, actually we're interested to know the height from the launch position to the maximum point. That's the maximum height we need. So that much you already discussed about. And the acceleration of the ball when it reaches its maximum height. What is the acceleration here? It is given as L. So it means at this point the object is said to be at rest. So no longer acceleration, but no longer should be acceleration is given as 9.81. Excuse me, should be this, not 0. Although velocity is given as 0 here, but acceleration it is actually 0. It is given as that one. And also let's have to appreciate this question. Of course, we already did the question which is similar to this one. So if a flare can jump straight up to a height of this one, what is the initial speed as it leaves the ground? That is, we're looking for the initial velocity. Now this is the case, should be initial velocity. How long is it in the air? Now we're looking for the d dot, of which now in this case it means this is the case of the motion. So we are looking for the d dot. That is question B. So try to have that out. And I also try this problem. A brick is dropped. It means the initial velocity is given as L. Being dropped. That from the roof of a building, for stop. The brick strikes the ground in 2.5 seconds. That's the Tmax. So you mean ignore the air resistance. So the brick is in a free fall. How tall is in meter the building is? We are looking for the height. So we have the time given as 2.5 seconds. So try to have that out on your own to have the height. I think the question B says that we should have to calculate the velocity of the brick as it strikes the ground. That is the final velocity, of which you can also try to have that out according to the way discussed. So those are some of the questions on a free fall motion I want to discuss with you about. So these are just part of the questions. So you should have to go through a lot of questions to be able to practice them. There are a lot of books with the questions to do with the free fall motion, or also on the internet. You can also have those questions via internet. So try to go through a lot of questions and practice more. You get used. Even in terms of the exams, you'll be able to pass it like much as you mastermind the concept. So thank you for your time.